Hello everybody and welcome to today's lesson on slopes of lines. See, I didn't forget this time. Alright, our objective is we will be able to use slope to determine if two lines are parallel, perpendicular, or neither of the two. Alright, and this is really a review of all concepts that we have already learned in Algebra 1. So let's get on with it. What is slope? Slope, another word to call slope, is the rate of change. The rate of change. And essentially, how does the y value change in context with the x value? And we have a number of formulas that we can use to figure that out. If we look at a graph, we usually determine the rise over the run. In other words, how far do we have to go up from one point to the other as we're going to the right from that same point to the next. And this gives us the difference, and this little triangle is the Greek letter delta, and we use that for difference. The difference in the y coordinate over the difference in the x coordinate. You may not have seen this so much before, but that is really what it means. Or in other words, you could say the change of y over the change of x and that brings us to our slope formula when we just go ahead and subtract the y coordinates from each other, y2 minus y1 over x2 minus x1, and all these things we call slope and use the lowercase letter m for slope. Don't ever use the capital M, okay? It's lowercase m. That is what slope stands for. Okay, I want you to take a minute now to, in your left margin, write an example of where you find slope outside of the classroom in your day-to-day life, at home, or in your community. Stop the video and take a minute to write an example down, and I will see you after that. All right, let's go to our first example and see what we're supposed to do here. Find the slope of the line containing the given points. So we are given points, and we need to use those points to find the slope. And when we have a situation like that, the easiest way to do it is using our slope formula that we had up here, right? Because that's the one that uses the two coordinates. Let's go ahead. Now the key is to remember which coordinates are which. Okay, so we're going to take a minute and mark them. We got x1 and y1 here, and why do we call them x1 and y1? Simply because that's our first point, right? And then we got x2 and y2 here, and the key is to put them in the right place and then do the integer math correctly, and then you're in good shape. So the slope for the line CD, I'm going to call this line CD, is equal to y2, which is 2, minus y1, and that is negative 3. So make sure you don't get confused with the minuses. I'm going to tell you that is the most common mistake made with the slope formula. Over x2, which is negative 4, minus x1, and that is positive 1. Okay, so let's go ahead and solve this. 2 minus negative 3 is the same as saying 2 plus 3 over negative 4 minus 1. Negative 4 minus 1 is negative 5. Both numbers are negative. They go in the same direction. In other words, we got 5 over negative 5, which is negative 1. There's your answer. And sometimes we would actually say -1/1. It helps us sometimes to use the fraction when we want to graph our line, because then it tells us right away, numerator one step down, denominator one step to the right. All right, let's look how this looks when we have actually horizontal and vertical lines. Horizontal lines have a slope of 0. All of them do. Every single horizontal line. And what should help you remember this is the mnemonic that you heard in Algebra 1, HOI. HOI stands for horizontal, 0, the O stands for the 0, 0 slope, and y is the only variable. What does that mean? Let's look at an example. Let's see. Let's assume we have this line. That looks pretty horizontal to me. And that line crosses the y-axis, doesn't cross the x-axis, crosses the y-axis, and I'm just going to say, for the sake of argument, that this line crosses the y-axis at the point 3. So the equation to this line is y is equal to 3. We need to know exactly where it crosses the y-axis, but we don't care about the x-coordinates, okay? No matter where we go, the y is always 3, and that's the equation. That's all we need to understand about this line. That's horizontal. And vertical lines. Vertical lines have a slope that is undefined. And again, there's the mnemonic that goes hand in hand with HOI, which is VUX. VUX stands for vertical, U for undefined slope, and now x is the only variable we really care about. Let's create a vertical line here. This is vertical, and it crosses the x-axis only. It doesn't cross the y-axis, and I'm going to just say it crosses the x-axis at -4. So then I can already go ahead and write our equation. The equation is x is equal to -4. That's all there is to horizontal and vertical lines. It's good to remember HOI and VUX. Remember HOI and VUX. Those tell you everything you need to know about horizontal and vertical lines. Their slope, their equation, and what they look like. All right, let's move on. Parallel lines. What can we say about the slope of parallel lines? Well, they have the same slope. Think about it. Two lines that are parallel, they never cross each other. They go alongside each other until eternity, infinity, and beyond sometimes. And these two lines, since they are going in the same direction, they have the same steepness. Sometimes we also call slope steepness, right? So therefore they have the same slope. We do have a symbol that we use for lines that are parallel. You have already met that symbol in the last class. And it's also two lines that are parallel. Okay, what about perpendicular lines? So perpendicular lines, we can also say something about their slopes, about the relationship between the two slopes of two lines that are perpendicular. Remember, perpendicular lines are lines that do cross each other, and they cross each other at a right angle. Only if this angle that they cross each other is a right angle do we actually call them perpendicular lines. This little drawing of mine almost looks like a man yelling for help, right? Never mind, you get the hint, right? So the slopes of two perpendicular lines are opposite reciprocals. Two things you need to know: opposite and reciprocal. Okay, sometimes we get one of them right, but then we forget the other. Opposite reciprocals. So think about it this way: if we have parallel lines, to get the slope from of one of the lines, knowing the other one, we don't have to do anything, right? For perpendicular lines, we have to do two things to find the slope of the perpendicular line given the slope of the original line. So it kind of like averages out, right? We do have a symbol for perpendicular lines, and again, it also looks like two perpendicular lines. They cross each other at a right angle. But let's talk about opposite reciprocal. What does that really mean? Here is an example. Let's say one line has a slope of 2/5. Then in order to find the slope of a line which is perpendicular, we need to do two things. We need to make that number 2/5 the opposite, and opposite means a positive number becomes negative, a negative number becomes positive. So since 2/5 is positive, the slope of our perpendicular line has to be negative, and then we need to also make it the reciprocal, reciprocal, remember? So we have to flip the fraction around and have 5/2 now. So in total, the slope of the second line will have to be negative 5/2. And there is another way to think about this. If you take those two slopes and you multiply them together, if we take 2/5 times negative 5/2, what do we get? We do get -1. And that will be always the case. Anytime you take the two slopes of two perpendicular lines and you multiply them, the answer is -1. That's another way to think about the opposite reciprocal. Two opposite reciprocals multiplied by each other will give you the answer -1 every time. Let's look at some examples. Find the slope of each line, then tell if the lines are parallel, perpendicular, or neither. Well, then let's go ahead and do that. Line 1 has a slope of m1 is equal to y2 minus y1 for minus 0 over x2 minus x1. And we get 4/6, which can be simplified to 2/3. All right. And then let's move on to line 2. I did want to change that color. Let's move on to M2. M2 has a slope of 6 minus 0 over 3 minus 7. And we get 6 over -4. And again, let's go ahead and simplify this. We get -3/2. Let's look at our two answers, 2/3 and -3/2. -3/2 is negative and 2/3 is positive, and they're also flipped fractions. They are opposite reciprocals, which means these two lines are perpendicular. Very good. So let's look at our next example. Line 1 has a slope of m1 is equal to -4 minus 2 over 0 minus -3. That'll give us -6 over, and here careful in the denominator, 0 minus -3, 0 plus 3 is +3, and that simplifies to -2/1, or just simply -2. Both answers are perfectly fine. And line 2 has a slope of -6 minus 2 over 2 minus -2, which is -8 over, and again, two minuses in the middle here make it a positive, make it an addition, over 4. Go ahead and simplify -2 over 1 or simply -2. And we can say these two answers are the same, two slopes are the same. Those two lines are parallel. We can also do that from lines that we see in a graph. Here in this example, let's look at lines A and B. We can find their slope by just picking 2 points, any 2 points on the line, and figuring out how to get from one to the other. I'm going to pick these 2 points, and what does it tell me? It tells me that to go from the point on the left to the one on the right, first I need to go down 1, that makes it negative, and 1 to the right. Our slope is -1 over 1, or just simply -1. And line 2, I'm using again 2 points. It could be any points on those lines, but which are the points that we like to pick the most? Of course, we would like to pick a point that is right on the grid lines of our graph. M2, if we go from the point on the left to the point on the right, we have to go 1 up and 1 to the right. And so this line has the slope of +1. Okay, so +1 over 1 and -1 over 1 isn't so apparent right away that these are actually reciprocals, and one of them is positive, one of them is negative. We can also test that out by doing the math, right? -1 times 1 is equal to -1, and that tells us these two lines are perpendicular. Moving on to the next example, we're going to look at lines C and D. Are they perpendicular, parallel, or anything at all? I'm going to try and pick in here. It's getting a little harder, but we still can find points that are right on the grid line. The slope of line C is going down 3 and 2 to the right, so -3/2. And the slope of line D, what are the points I'm going to use here? Maybe these two, that work out fine. I'm going to go down 2 and 1 to the right to get from the left point to the right point. And we got our two slopes here. You can write the slope of line D as -2, not making it a fraction. Both are perfectly fine. Again, the fraction is helpful when we want to actually go ahead and graph the line. It tells us how many steps up or down, how many steps to the right. Let's look at two slopes. Well, they're both negative, but they're not the same. So they're neither parallel nor perpendicular. Okay, guys, so much for this. Now go ahead and watch the second part of this tutorial.